So here's an interesting example. Find the volume of the solid generated by revolving the region bounded by y equals square root of x, y equals 2, and x equals 0, and that's drawn right here. First about the y-axis, then about the x-axis, then about the line y equals 2, then about the line x equals 4. So first about the y-axis, that's this way. So if I revolved about the y-axis, note y equals square root of x, but I'd need it as x as a function of y, so I'm going to wind up with x equals y squared from that. And so revolving that about the y-axis, I'm going to go from y equals 0 to y equals 2. The outer function is x equals y squared. The inner function is just the axis itself, so minus 0. This is just strictly a disk problem. And so we got pi times integral from 0 to 2 of y squared squared, that's y to the fourth, minus 0. dy is the thickness of the disk. So that winds up as 32 pi over 5. Part B says same thing, only rotated about the x-axis. So rotate this about the x-axis. And here I have it sketched. It looks something like this. The gray area is hollow, and the area I'm trying to find is this clear area here, and I drew in a sample washer. X would be going from 0 to 4. We're going to be adding up washers from 0 to 4. The outer edge of the washer is length 2, so that outer is 2 squared, or the r squared is 2 squared. The inner is y equals square root of x, and when you square that you just get x, so we wind up integrating pi times integral from 0 to 4 of 4 minus x dx, and that's a pretty simple integral, and you can probably work this out without too much trouble and see that the answer is 8 pi for this region. Backing up, then about the line, this region about the line y equals 2, that's going to be an odd shaped thing. And here I drew it, and I drew in a little sample disk. This is going to be strictly a disk method. And we have to be very careful when we find the radius of this, because the radius of this is going to be 2 minus the square root of x. That's the upper minus the lower. Or we could say square root of x minus 2. It doesn't matter because we're going to square it anyway. And we're going to add those disks up from 0 to 4. We're going to multiply by pi, because that's how you find the volume of a disk. Pi times the radius of the disk squared times the thickness of the disk, and hopefully you see where all those parts come from. And I think once you get that set up, the integral itself is kind of like ridiculously simple. 4x from this part, that's x to the 1/2, so it's 4 times x to the 3/2 divided by 3/2, but that's like times 2/3, so make that negative 8/3 times x to the 3/2. Integral of x is x squared over 2. When we put in 0, all these terms will be 0, so that's nice. We put in 4, we got 16. Put in 4, the cube root of the square root, sorry, the cube of the square root of 4 is the cube of 2, which is 8. So it winds up being 64/3, and then put in 4 here, we got 16 over 2, which is also 8. So we got 16 plus 8, which is 24, which is 72/3, minus 64/3, so 8/3. 8/3 times pi. Finally, we're going to take this same region, rotate it about the line x equals 4. And it gives us the clear region here. I drew in a sample disk. So, okay, now this time, pi, interval is 0 to 2, because this is going to be using y as a reference variable. The outer radius is 4. It's 8 minus 4 if you want to think of it like that, or it's 0 minus 4 and you square it anyway, so it wouldn't matter. You still get 16 for this part. Keep in mind this was y equals the square root of x, and so x would be equal to y squared, and so this inner radius is 4 minus y squared, and then we have to square that. So remember, x equals 4 to x equals y squared. That's how far this radius is, okay? This inner radius. And we're subtracting the square of that because it's the washer formula. So we've got integral from 0 to 2. It's actually the whole integral is times pi. 16 minus 8y squared plus y to the 4th. That's just algebraically working this out. Hopefully that's the easy problem. And then put in, well, let's integrate that. After we simplify it, the 16's cancel out, and minus negative 8y squared is 8y squared minus y to the 4th. And so integrating that, we get 8y cubed over 3 minus y to the 5th over 5. From 0 to 2, when we put in 0, everything vanishes, so we put in the 2 to get the important part. That's 64 thirds. Pi times 64 thirds minus 32 fifths, and that means 224 pi over 15. You'd have to add the fraction to see that that's true. If you want, it's 5 times 64, that's 320 minus 96 over 15. And that's 224 pi over 15. The region of this clear region, not the gray region.